Welcome everyone. My name is Naga Kavya. I am pursuing BTech in Sri Venkateswara College of Engineering in the Department of Electrical and Electronics Engineering. Now let us see what I have did in Embedded Systems internship. Firstly, I have learned about the basics of C programming. C is a powerful general-purpose programming language developed in early 1970s. It was initially developed by Dennis Ritchie in year 1972. C language is also known as mother of programming languages due to its influence on many modern languages. C language syntax and features have been adopted by languages like C++, Java, and Python, making it a foundational language for many programming paradigms. Library facilities in C plays a important role. Now we can see where C is used. C program is popular and widely used programming languages where it can be used in building databases, designing compilers, developing operating systems, graphical user interface, game and animation, embedded software development, and many more applications. C is used. Now let us see the syntax of C. This is the syntax of C programming, whereas these are the header files of C programming. We can use different types of header files, and this is called user defined function, and this is function calling. This is all about the syntax of C programming. Now let us see the data types and modifiers of C. There are three types of data types in C programming. The first one is primitive type, and the second one is derived type, and third one is user defined type. In primitive data type, we have four types: character, integer, float or double, and void. In derived data types, there are three types: signed, unsigned, long, double, and the user defined data type, which are defined by the users. And the user defined data types are array, struct, union, enum. Now let us see the modifiers of C. These four are known as modifiers of C. The first one is short, and second one is long, and the third one is signed, and the final one is unsigned. Now let us see the keywords in C programming. These are the keywords in C programming. Actually, there are around 32 keywords in standard C. In C programming language, keywords are reserved words that have predefined meaning and cannot be used as identifiers of variables or function names. Usually keywords are already derived in the C programming. So these keywords are not used in variables. Now let us see the conditional constructs. These are the conditional statements in C: if else and switch. In if else there are around four types. The first one is if, and the second one is if else, and third one is if else if, and the fourth one is nested if, and the final one is switch case, where different types of cases are used here. And these are the syntaxes of the different types of conditional statements. Now let us see the looping statements. There are three types of looping statements in C, and the first one is for loop, and second one is while loop, and the third one is do while loop. For loop, for loop is used whenever we know the number of iterations, and while loop is used when number of iterations is unknown, and do while loop is used to execute the condition at least for once. And these are the syntaxes of the looping statements. We can see for loop, first initialization and then condition, later updating. Whereas when we see while loop, first it checks for condition, then go for statements, and finally do while loop. Let us see. First, it checks the statements. After, it will check for the condition. So it will execute the condition at least for one time. And these are about the looping statements in C programming. Now let us see. This is the main part of our internship, embedded system. Let us see what is embedded system. Embedded system is a computational system that is developed based on an integration of both hardware and software in order to perform a given task. What I'm going to say is embedded system is a combination of both software and hardware to perform a given task. So embedded system can be said as dedicated computer system has developed for some particular reason, but it is not our traditional computer system or general purpose computers. There are embedded systems that may work independently or attached to a larger system to work on a few specific functions. These embedded systems can work without human intervention or with little human intervention. Like examples for embedded system, we can see digital watches, washing machine, smartphones, and automotive systems. There are many applications of embedded systems in real world. Embedded systems are found in a wide range of applications, from consumer electronics to industrial machinery and medical devices. This is the main part of the embedded system. Now let us see an example of embedded system. Washing machine. Washing machine is the example of embedded system. We can see there are different modes of control the washing machine, like selecting the load knob, selecting water level. Embedded systems control the washing cycle, water temperature, and spin speed in washing machines. They make the machine work more efficiently using less water and energy. Mode selection knob, program select knob. This is the working of washing machine using embedded systems. Now let us see the components of embedded system. We can see here these are the components of embedded system. Mainly all the components are connected to CPU, and the remaining components are A&D conversion, user interface, diagnostic port, AUX system, D&A conversion, memory, software, F- FPGA, and sensors, actuators, electromechanical backup, and safety. External environment. This all about the components of embedded system. And the requirements of embedded systems are reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. So these are the requirements of the embedded system. Now, when coming to our project on embedded systems, this is the problem statement. We have to develop a washing machine interface and simulate it, which displays and allow user to select different types and allow user to select different types of washing modes and pressing digital keypads and water levels on long press. On start of machine, it should display function running and remaining time, and also it should stop when the lid is opened. This is the problem statement. We have to do the project based on this problem statement, and I did the project based on this problem statement. Now let us see the software required for executing the project. These are the softwares required for the project. The first one is MPLAB XIDE V5.50 and XC8 compiler and PiximLab. These are the main software required for embedded system. And this is the architecture of the board. And when coming to the parts of the board, this mainly LED is used. We can see LED is used for indication purpose. A light emitting diode is a semiconductor device that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. And the color of light is determined by the energy required for electrons to cross the band gap of the semiconductor. Now, let us see the parts of the LED. There will be a two terminals for LED, and the first one is cathode, which is indicated with negative symbol, and the second one is anode, which is indicated with plus symbol, and this part is known as flat spot, and this is post, and this part is also known as bond wire, anvil, reflective cavity, LED chip, epoxy lens, and this is the emitted light. This is about the LED, light emitting diode. Now let us see the CLCD. CLCD is also known as character liquid crystal display, which can be used to display the messages like alphanumeric LCD display module, meaning can display alphabets and numbers. And CLCD contains 4 rows and each row can print around 16 characters. And it can work on both 8-bit and 4-bit mode. And CLCD has D0 to D7 on the data transfer lines, RS to 0 for instruction register and 1 for data register. And CLCD enables PIN and RW pins. Now let us move on to the next topic. Tactile switches. Tactile switches is also a part of the microcontroller. See, there are two types of switches that often get mixed up or have their names used interchangeably are tactile switches and push button switches. While these tactile switches are similar in nature and function, push button switches are built with traditional switch contact mechanisms. In contrast, tactile switches utilize membrane switch type contacts in their construction. Now let us go for some more parts like ISR, fan, buzzer. These are the some more parts in microcontroller. Now let us see ISR. An ISR is a special function that runs automatically when an interrupt happens. Like interrupt means something urgent happens like a button press or sensor detecting something. And now when coming to next part, fan. Fan is a key component of many electronic devices designed to provide active cooling by moving air. Fan speed and operation are often controlled by microcontroller. A fan is a output device to blow air or cool down a circuit or a system. You can control a fan using a relay, transistor, or motor driver. And the another part of the microcontroller is buzzer. Buzzer makes a sound when turned on, and buzzer is used for alerts, alarms, or notifications. Buzzer also has two terminals and one pin 1 and another one is pin 2. Pin 1 is for VCC and pin 2 is for ground. And this is all about the parts and C programming. Now let us go for project demo. First of all, I am going to show the microcontroller. This is the microcontroller we are going to use in this project. Now let us see the parts. These are the switches of the microcontroller, and this is switch 1, RB1 is switch 2, and this is switch 3, switch 4, switch 5 and switch 6. These are the LEDs which can be used for indication purpose. This is the port B LED and this is the port D LED. And we have some ports also which contains different types of control resistors. This is port A, port B, port C and port D. Port A consists of trace A, port B consists of trace B, port C consists of trace C and finally port D consists of trace D. And when coming to the remaining parts, this is the fan. As I have said before, it can be used for cooling purpose. And this is the buzzer which can be used for alerting purpose and give notifications also. And these are the ports, remaining ports. This is relay 1 and this is relay 2. Now let us go for the coding part of the project. This is the coding part of the washing machine project. I have created a project named it as washing machine. And these are the files in my project. First of all, to create a project, go to MP Lab, click on File and go to Next Project. And here we have to choose microchip embedded and application project in projects here, and we have to click Next and we have to select in families mid-range 8-bit MCUs and device and device pick 16, sorry, and the device is pick 16F877A. This is the device which we are going to use in this project, and when we click next, the project file will be created by selecting the program files, and when we click next, the project file will be created. So like this I have created the project file. Now coming to our project, which I have created the file before itself only. These are the files in our project: header files, important files, linker files, source files, libraries and loadables. Header files contain all the headers which will be used in this program. Like we can see, header files contain some more files like clcd.h, digital keypad.h, main.h, timers.h, washing machine header.h. This is the files in header files. Now let us go Let us see each files. clcd.h. clcd.h. It contains all the header files which includes about the clcd display. Now let us see digital keypad.h. Digital keypad.h. This file contains all the header files about the digital keypad. Now let us see main.h file. Main.h file also contains the all the header files which will be used for further purpose in this project. And when coming to timers.h, these are the header files related to timers. And finally, washing machine header file. These are the header files related to the washing machine. Now let us see source files. In source files, we have clcd.c, digitalkeypad.c, main.c, timers.c. clcd contains the display part. This is the code of the clcd. Now let us see the digital keypad.c file. This is the code for digital keypad. And finally coming to the main.c file. This is the main.c file which contains initial clcd function. This can be used for display purpose, and this is an initial digital keypad. This can be used for display and digital keypad, and this is the timex function. GINPERE used for interrupts. Initially buzzer and fan are in off condition, and these are the macros created for buzzer and fan. This is the initial configuration. Initially these lines are displayed in CLCD, so we have used this CLCD print function. Press key 5 to power on washing machine. These three lines should be displayed initially, and this is the remaining coding part, and these are the navigation part. Now let us see the timers.c. And this is the timers file. Let's go for washing machine function. This is the main part of the washing machine. Initially, while using washing machine, we have to check the options based on the load. Like here, some operating conditions are given based on the load, like daily, heavy, delicates, whites, time wash, eco cottons. Like this, some conditions are given based on the load. We can select as our wish, and this is the water level. Five water levels are declared here: auto, low, medium, high, and max. And this is the remaining coding part. See, if we press the switch 4, clear screen will be happened, and this is the remaining coding part of the program. These are the navigations used in washing machine project. Now let us build this project. See, This project file is built successfully. Now let us go to Pixie Lab and dump the code. So this is the Pixie Lab. I'm going to dump the code here. After dumping the code, let us see. We can see here, press key 5 to power on the washing machine. So I'm going to press key 5. Washing machine is power on. Now these are the options to select based on the load. Now I am going to switch 4. See, if we click it is navigating. So we can select the water level here. Now to start the program, press switch 5. So this is the, if we press the switch, the buzzer is on due to the door is open. So to start the program, we have to press the switch 5, or to pass the program, we have to press the switch 6. Now I am going to pass the program. See, the program is passed. And the fan also stopped. Now I am going to start the program again. Yeah, the fan also started here. I have started the program. After finishing the program, the fan will get stopped and buzzer will ring, and the timer is going to finish. Let us see. The program is finished, so the buzzer has been rang. This is about the washing machine programming project using embedded systems, and the microcontroller used here is PIC16F877A, and the frequency also selected to 20 20 megahertz. This is all about the washing machine interface using embedded system. I have learned I have learned something using this project. Thank you for giving me this opportunity. Thank you for Emertxe company to show our skills and execute the program. And thank you. Thank you, Emertxe company.